I'm very happy to see everybody today, and I am Evgeniya, and I will talk about our library created at Toloka, CrowdKit, and we will, of course, go through it slowly with right amount of understanding, like why this library is even needed, what are crowdsourced annotations, why we're referring to Scikit-Learn, and like what is it all about. So let's start with a problem that we are trying to solve having this library, and let's a little bit dig in this world of crowdsourced annotations. So imagine, or you don't have even to imagine that you're a machine learning engineer, and or you're just a big company, or not even a big company, and you're having a problem of you want to have some machine learning solution, but you don't have data for it. For example, you're an app, you have negative and positive reviews in App Store, and there are so many that you need to classify them beforehand to pay attention only at valuable negative ones, to create some corrections to your product and make it better. And of course, you want to do it automatically, but for that, for learning a machine learning algorithm, for example, you need some data, some reviews previously classified for you. Or even more interesting task. Let's imagine you're a self-driving car architect and you want to train your car how to operate in a city. But before like getting it out to operate with the real humans and everything, you would prefer it to be trained to very well distinguish between like road signs, between red and green light, and like between humans and like, I don't know, some lights. So you need to get the data, you need to get a data set labeled. And of course, there are like a lot of options for that. Synthetic data, finding them in open source, but usually domains are pretty much uncovered. So for dataset labeling, you need somebody to do it manually. And when it comes to manual labeling, sometimes people are like having experts in their companies for labeling, and they're paying them some money, and it's also an option. But usually in machine learning, you need like a big piles of data. And here comes one of the options how to gather this data, which is crowdsourcing. Just imagine that you're having some platform where you can like register your task, decompose it, and send it to like thousands of humans. For example, you want to gather the data set of pictures, and like you're giving like one annotator one picture and asking to give some result on this picture. Of course, when you have thousands of people working with your data, you pretty much can be sure that it's scalable and you will have like a big amount of data as a result. But the problem is quality of data. Like here, you're not sure in anything. When you're working with your home expert, it's understandable that the result will be very good. But if you're working with somebody who haven't signed a contract or anything, you don't know that the result will be high quality. And here comes a very simple technique how to ensure quality in your data, which comes from the phrase that two heads are better than one. When you're giving it to crowdsourcing, you better like check opinions of the crowd and the different data labeled and gathered with the multiple different people not meeting each other. So for example, you give them one picture to three people, and you ask them to give some result, like some hello world problem of crowdsourcing science, like tell me, is it a cat or a dog? Okay, so you have now a huge tons of raw data, and you need somehow to get still one label out of it. And here comes the other question, like we're solving one problem, we're having another problem coming at us. How to aggregate it, how to get the final result, which is high quality and good enough for our models, for our production, for everything. And pretty much natural way, which like I guess everybody of you will guess it. It's easy to understand when you're like giving some information, some fact to a multiple crowd of people, and they're giving, for example, like categorical answers like yes or no. The overall answer is just a majority vote. You're like saying, okay, these two said yes, this one said no, I will listen to less of the people. So yeah, that was like the simplest idea of aggregation with categorical data. Then let's imagine that you had some knowledge about the data labeled, and you need some ground truth answers, and you evaluated post factum answers of this crowd, and you realize that one person is giving answers in 19% of the cases correct and other in 50, and you're like, okay, why would I even listen to the one who gives answer in a 50% of the cases incorrect? So you're evaluating this, you're using this overall scale, estimated quality of a person, and you're creating, boom, a weighted majority rule. And still, like, you're listening to me now and like, okay, I'm in a PyData conference. I know how to write one-liner, which does this, and I don't need any library, and I'll pretty much agree with you. But when it comes to crowdsourcing, the beautiful part of it that any type of a data can be gathered with a cloud of annotators. For example, it can be pairwise comparisons. Let's say you have interfaces and you want to like make your app looking better. So you're asking people what is better, like interface A or interface B. And here you can also ask multiple people, but the answer is pretty much subjective. So here, when it comes to aggregation, you need to think of something more smart than just doing a majority vote. Or imagine you have a textual responses. You're gathering captions for your images to train some image to text big model, and people are answering pretty much the same, but with some difference in letters, in like articles or something. You can try to do a majority vote over letters, but it still sounds not like as simple to do and is fast to do. And even when it comes to images and segmentations, also you can solve this task with, for example, like pixel-wise majority vote, but still very hard. You're not sure that it will work fast. It's not easy to write. And here comes CrowdKit. And we created CrowdKit as a data science library, which will be very easy to start using for people who already work with such machine learning libraries as NumPy, CPy, or especially Scikit-Learn, the one that I used for my title. And why we try to do that? Because datasets gathering is one of the big parts of the machine learning pipeline. So I really want any engineer working with a whole over machine learning pipeline in Python being able to hop on in any library, knowing already how in general they work and which methods in general they have, and not having to study from the beginning some documentation of some new library. So we tried, while building our CrowdKit, to base it on the same principles of API as Scikit-Learn based. And let me a little bit like discuss them. Their consistency, which is, I guess, pretty well known for engineers. It's like in every element of the interface, every interface is implemented consistently with a limited amount of methods and like performs as expected. So in different parts of the system, you have the same outcome. It's inspection. So we have these black boxes in Scikit-Learn machine learning algorithms, which are getting learned by some parameters, and then they are doing predictions on some data. And all of these parameters gathered through learning and predictions there can be accessed by a user. Everything should be transparent. The same is in CrowdKit with its black boxes and its aggregation algorithms. It's non-proliferation of classes. You're not complicating your code. You're creating specific interfaces only for your black boxes or learning algorithms or aggregating algorithms. It's composition. Every machine learner and I guess every engineer understands that every system is built from the basic building blocks. So you should be able to access them and combine them in different ways to create more complex pipelines. And finally, it's sensible defaults. So when you're creating your black box algorithm, sometimes you don't want to like toggle tune every micro parameter. For example, like how many times you look at your input data or something. So defaults which are selected should work moderately good. So we did the same. And to make a good comparison of CrowdKit and explain why it's simple to use if you are an engineer which worked already with all data science libraries, I want to give a small recap for people maybe who haven't used it that much or for some time to understand the parallels that I will try to draw. So Scikit-Learn has interface design, which consists of 3 interfaces. And the first major one is estimator, which has a fit method. To explain it very simply is just you have like a big container, a black box, an algorithm, machine learning algorithm, which is being learned. And it's firstly instantiated with some parameters which are crucial for this particular algorithm. And then separately, it's being learned on data. So you have a data on which you learn some patterns, and then you can predict results on unseen data. That's how technically machine learning works. And it's based on the partial function application idea, as you can see here on the small sketch. It's when you're freezing a function with already some parameters, and then you're passing it by. So estimators are more about learning. Predictors, it's an extension of estimator interface, which can predict already on unseen data. Algorithm learns, and then it predicts the results. And also they have transformers, which transform data. So as input, what is like the beauty of these machine learning libraries, you pretty much can put in anything that you want, any data, and get an output which will already like give some predictions which are crucial to you in very different tasks. So data should be in matrix format, and it doesn't matter how many rows or columns do you have in this matrix, and you can use pretty much everything like NumPy, SciPy, pandas, or whatever. And here is an example, how does it look? And here you can exactly pay attention to the last lines when it's like just instantiating an algorithm, which is linear regression here, and then just running a simple like learning procedure with fit and predicting. So you're not doing something as a rocket science, you're just calling to methods. And we try to do the same. We try to build it on the same principles, as I said, to make machine learning pipelines as much smooth as possible and adding our part with the data-centric AI. So interfaces, we created basically the same idea of predictors that are in Scikit-Learn, but the difference with crowdsourced annotations, that methods very much differ based on the data type that you're working with. So for example, if classification requires like aggregating, which can be based on some prior knowledge about the label, and we're thinking that it's pretty much objective, so there is actually a true label to this data. Then, for example, pairwise aggregations, when you're like saying what is better, there is only subjective knowledge, so we can't use any label prior knowledge. We doesn't know what is actually better in this pairwise comparison. So we're using other models. So here you can see 5 types of interfaces based on a data annotated type, but they're using the same methods which are well known for a data scientist, which are fit and predict. That's why I'm saying that we have the same idea as predictors in Scikit-Learn. So you can the same way call learning, call predicting, and the same way of decoupling the interface. So your firstly instantiation, performing an instantiation of your basic aggregator, and then you're like feeding to it any type of crowdsourced data. CrowdKit is platform agnostic, and receiving the result. As an input, it also uses pandas, so it uses a very well-known library. You don't need to find out about some complex new data types that you never seen in your life. The one difference with the Scikit-Learn, here it's very important what amount of columns do you have in your matrix data, because for using and crowdsourcing aggregation, you need to know who labeled what and how. So for that, you have to specify columns, which, for example, NumPy can't do. In the end, however, it works pretty much the same. And I want to present an example of how CrowdKit works. And so here we're taking a very well-known data set with ranking of complexity of 2 texts, passage A and passage B. This is exactly the pairwise comparison. And we wanted to test how crowdsourced annotations are working on it. So we're taking these 2 passages, this gathered data set, and we're going it through the crowdsourcing labeling separately. And we're checking like this labeling, how it's happening, what crowd is choosing, what is more hard to read, passage A or passage B. Here you can see the results of labeling. the worker who did it, left and right passage, and the result, what was more complicated. And then we are performing an aggregation with our models. As you can see here, it works in the same way as Scikit-Learn works. So you're importing methods, you're instantiating them with parameters, and you're running fit predict. And what are these models doing? These models actually taking an aggregation, and they are ordering the texts from the easiest one by the opinion of the crowd to the hardest one by opinion of the crowd, and then assigning them some score. So the score will be 1 if it's the hardest text ever, and it will be 0 if it's like the easiest text. And here ground truth depicts like the hardness level of the text from 0 to 12. So like for example 11, it's a very hard text, and if you see near noisy bread literary model gives it also a result very close to 1. So crowd actually performs the labeling very correct. And what do we have in this library? What can you use? Which methods, which models, how to assess it now and start using it immediately? So there are aggregation methods based on 4 types of data: categorical, textual, image, and pairwise. You can see here the methods implemented. You can access them in GitHub, and you can try them like right away in the same manner as you can try Scikit-Learn. There are data sets also in the same manner as there are basic ones for playing around with your proof of conceptions in Scikit-Learn. We gathered them themselves on Toloka. There are crowdsourced data sets, and you can read the description and use them for your tasks, not only for like aggregating something, but also for some proving some ideas, some hypotheses related to machine learning or else. And there are also in the same manner metrics which depict the quality of aggregation, the quality of annotation, and the quality of overall result. So to bring it to the conclusion and smoothly transition to maybe Q&A or some discussion, we have a CrowdKit, which is based on the same principles of Scikit-Learn. Of course, they are not equal because Scikit-Learn is here, exists for many years, and it's a very famous, as far as I recall, like 60-second package in the queue like of popularity ever being downloaded, and we're just a small thingy, but still it's based on the same principles. It's designed for using it handfully in your machine learning pipelines. It's platform agnostic, can be used with any type of crowdsourced annotations, and it actually will help you to gather big high quality data sets for machine learning. Here you can find some links if somebody is interested to look at the GitHub, give some suggestions, give some comments. We're super happy to answer and to provide like explanations how to use it and where to use it. And that's the end of my talk. I was very fast, I think. And I am super happy to answer any questions, super happy to connect, and just super happy to present here today. Thank you very much.
Well, thank you, Evgeniya. That was a very, very nice talk, and I really like the concepts and the motivation behind CrowdKit. So yes, we have plenty of time to for Q&A. So those participating in chat right now, feel free to write your questions, and I can bring them on screen for Evgeniya to answer if necessary. There's nothing so far. Let's just give it just a few more minutes. While we're waiting for the first question, I was just a bit curious in terms of contributing to CrowdKit. In fact, where can we find sort of like the documentation or guides for contributing?
Oh, let me actually, can I send them in chat, or maybe I can send them to you and you can send them in chat?
Yes, of course. Actually, in fact, perhaps we can post about on Discord the link to that. You could share it with me as well, and I can send it whichever is most convenient.
Yeah, that's exactly what I will do. But it's pretty much easy to find because it's called CrowdKit and it's like the first link on GitHub that you will Google. So I would say we made it super easy.
There you go. You beat the SEO.
Yes, we hacked Google completely. So I'm sending you the link And I'm sending you a second link because I have plenty of links to send.
Excellent, thank you. And I will share them in Discord.
Thank you very much.
Shortly.
And yes, if anybody wants to contribute or has some ideas where it can be like improved, or maybe is interested in some data type which they have used, for example, like audio, because audio annotation is used a lot in the voice assistants. For example, you're training your mini Alexa and you're gathering this like voice overs from a crowdsourcing, and then you're thinking how to aggregate audio because it's a very complex one. We had ideas, we had some models for aggregation, but we didn't implement it yet because of the we thought that it can be postponed, but maybe somebody is interested and it will like speed us up. So I'm like searching for motivation here, you know.
Yeah. I think that could be an interesting use case for audio crowdsourcing. There is a question in chat. I'll bring it up on screen and I'll read it up. So it's a question from Indemir. Is support for deep learning frameworks, Keras, PyTorch, etc., coming or already there?
It's okay. So it's a nice question. I really want to know where it's coming from, because it's definitely like a person thinking how to apply these aggregations in some deep learning neural networks, which is actually like a case, for example, for convolutions or something. I am, as a machine learning engineer in the past, very happy for this question, but you don't need any support technically, because here you're just getting your data. Um, Maybe I understand it from the part that you wanna, for example, have a result, your data in some PyTorch format, on in some Keras format, or like in the tensor flows, like in tensors. Uh, I am not sure that it can be done in tensors, considering that we're having this panda structure, because it's very important to have these three columns, like a worker, label, and object. But I can think of somehow of transferring these data types and make them easily accessible for the deep learning neural networks. But I would say pretty much you already can use it. So I don't think there is like a much support needed. Or if you see any ways that you wanted to see it, then please contact us and we will think about it.
Yeah.
Because
Yeah, perhaps there's a link there to actually create like a data sets package, a link between a CrowdKit and a data sets. Like I remember Hugging Face has a data sets package, which is sort of also inherited from TensorFlow and inherited from somewhere else as well. So great. There is one more question. There we go. Killian, how would you aggregate, say, 50 limit results for one example when it is a highly subjective yes or no question? Could an average be done, do you think?
So I mean, it depends on which data type was labeled. So was it like, for example, as I was talking about the pairwise comparisons, they're very subjective. So it's like better, worse. So I won't take into the deep how Bradley Terry works, or like noisy Bradley Terry, which are models for exactly these types of like subjective answers. But I would recommend to use in this case, just in general, like so when you're working with crowdsourcing, you usually have some knowledge about the people who are this crowd. You have some features which are describing them, and you can create a trustworthy feature also. So firstly, pre-filtering of the results should be based on the trustworthiness, in the means that person are actually thinking that, and the result is actually his honest opinion. And then I would say an average based, like, expectation maximization algorithm based on like some their trustworthiness skills, or average, or depends on the task. I would say depends on the task. But I am interested why 50, and I'm very much interested which data type you meant. And if you have any like particular task, please come to me. I will be happy to discuss the particular case. Thank you very much for the questions, guys.
Yes, good questions. So, Killian, I'll encourage you to again post your question on Discord and reach out to Evgeniya, if not via Discord, via other methods that you mentioned earlier as well.
Super.
Great. We have time to field one more question if anyone has any. I don't
Yeah,
see.
and I definitely agree with the comment about the upstream of deep learning. That was a very right one. Thank you very much. I am in a very talk mood, so that's why I'm answering question not with the 3 words, but 33. But yes, that was a very nice summarization.